So, good news! You survived to the end of the chapter. All we're going to do now is one last review video to summarize what we've learned since the last time. So let's start with position, velocity, and acceleration problems. To get instantaneous velocity, which is 1 point, you either do the derivative of position or the slope of the position graph. To get average velocity, which requires 2 points, you do regular old slope, or you could do the slope of the position graph between 2 points. To get acceleration, which again has 1 point, you do the derivative of velocity. To get speed, you do the absolute value of velocity. And to get displacement, you do final position minus initial position. To determine whether you are moving right, left, or whether you are stopped when your velocity equals 0, or it is the maximums and minimums of a position graph. You're moving right when your velocity is positive, is positive, or it's when you have an uphill slope on a position graph. And you're moving left when your velocity is negative, or when you have a downhill slope of a position graph. My hint to you is, you can't see what I'm writing. My hint to you is look at what I'm writing and make a chart, because charts are your friends here. Last but not least, speeding up or slowing down. You are speeding up when velocity and acceleration have the same sign. So you're looking for either uphill and above, or downhill and below. You are slowing down when your velocity and acceleration have opposite signs. So you are looking for uphill and below, or downhill and above. Or if you don't have a graph, make a chart. These are your friends. Charts are your new friends. On the next page, we've learned a couple derivative rules. First, we learned that the derivative of sine is just cosine. We learned that the derivative of cosine is negative sine. And the derivative of tangent would be secant squared. We also learned the derivative of cosecant is negative cosecant cotangent. The derivative of secant is secant tangent being multiplied together. And the derivative of cotangent is negative cosecant squared. Last but not least, we learned about chain rule, which says if you're trying to take the derivative of a function that is nested inside of another function, if there's layers of functions, then the rule is you take the derivative of the outside function, you leave the inside function alone. Then you make a chain, you multiply by the derivative of the inside function. So an example of a chain rule problem would be this one. My outer layer would be cosine. My next layer would be sine. And my innermost layer would be 5x to the 5th. So my derivative, you'll note that I'm changing notations there because I'm taking the derivative now, would be negative sine, leave the inside alone. Times the next layer's derivative would be cosine, leave the inside alone, times 25x to the 4th. If I just make this look pretty, I'm going to take the 25x to the 4th, I'm going to take the negative, and I'm going to put them at the beginning. And I'm going to leave everything else alone. And I'm done. That's it, folks. We're done. We made it. Woohoo! We learned a lot of stuff in this chapter. Be ready to review tomorrow.